So we're given the following equation. X squared over 4 plus y squared over 36 equals 1. And the first question I want to ask you is the following. If we were to graph this, is the result an ellipse or is this a hyperbola? And how do you know that? How can you make that determination? Well, the answer to that is indeed it's an ellipse. And the reason it's an ellipse is because there is a plus sign. If there was a minus sign between these two things, it would be a hyperbola. But the fact that there is a plus between elements of this form makes it an ellipse. Now, from this ellipse, we want to determine what are our 4 vertices. An ellipse has 4 vertices. So think about what those are, and then answer the following question. The issue is 4 and 36, because our general form for an ellipse, if it starts with x, would be x squared over a squared plus y squared over b squared equals 1. And in this situation, the center is at 0, 0. This is our simplest case. Well, if we're going to go ahead and compare this to the original x squared over 4 plus y squared over 36 equals 1. A squared is 4. So a is, well, you could say plus or minus 2, but we're going to stick with the positive 2. B squared is 36. So b is 6. So starting at the center, what are we going to do? We're going to start at the center and we're going to go 2 units in the x direction and 6 units in the y direction to go ahead and get our 4 vertices. So let's go ahead and do that. I'm going to pull up Desmos here so we can take a look at that. So our center, and let's see, is 0, 0. So we'll go ahead and put our center in at 0, 0. And we said we need to go 2 units in the x direction. So 2 units to the right to 2, 0, 2 units to the left, negative 2, 0. And then we had to go 6 units up and 6 units down. So from 0 up 6, so 0, 6, down 6, 0, negative 6. So those are the 4 vertices. We've established those, and we can use those to construct our graph by hand. So if we were drawing this, we would connect those 4 dots. And what's the result that we have? It should look like the following. X squared over 4 plus y squared over 36 equals 1. And indeed, you can see that. So we have our 4 vertices, we have our center, and we're able to go ahead and construct a graph. And there's one other question that we like to ask, namely, where are the focuses or foci? You have 2 focuses, sometimes the plural is foci. I want you to go ahead and tell me what the 2 focuses would be for this ellipse. So answer that question, please. And what was our original question? X squared over 4 plus y squared over 36 equals 1. Our center is 0, 0. Now, where are the foci? Are they on the x-axis portion or on the y-axis portion? Let's go back and take a look at our graph again. Are the two focuses on this portion or on this portion? The answer to that question is the two focuses always lie on the major axis. So the two focuses will lie on this portion of the graph. We need to go ahead and find out where. So what is our general formula for the foci for an ellipse? C squared is the bigger number minus the smaller number. So it's either a squared minus b squared if that's positive, or c squared is b squared minus a squared if that's positive. So if you're calling this a squared and calling that b squared, that'll go ahead and give it to us. And we'll say c squared is 36 minus 4. C squared is 32. We're only dealing with the positives. Well, maybe not. I guess we could think of it as plus or minus. C is plus or minus root 32, which is plus or minus root 16 root 2, which is plus or minus 4 root 2 from the origin, from the center. Our center was 0, 0. We're going to go up 4 root 2. We're going to go down 4 root 2. So those numbers will be, the x value is 0, the y value is 4 root 2. The x value here is 0, the y value is negative 4 root 2. There would be our two focuses for this ellipse. So let's go ahead and put those back on Desmos. Take a look at it. So we have our two ellipses, we have our two focuses, 0, 4 times the square root of 2 is one of them. And 0, negative 4 times the square root of 2. And remember what the focuses represent. If we had two pins on a bulletin board and a piece of string connected to them, the sum of the two distances is always constant. So envision pulling this string around all the way around the ellipse. Those two distances, like the distance from here to here, plus the distance from there to there, is the same as the distance from here to here, plus the distance from there to there. That's our definition of an ellipse. Let's take a look at another example. So this time I will take a look at the following. We will look at y squared over 9 minus x squared over 16 equals 1. So the question I'm going to ask you now is this an ellipse? Or is this a hyperbola? And why? Well, our form, right, is still the same. Something squared over a number minus something squared over a number equals 1. But if there's a minus sign in the middle, this is a hyperbola. So the next question I'm going to ask you is, what is the transverse axis? What do we mean by transverse axis? Well, if we have a hyperbola that looks like this, the transverse axis is the mirror that would split it in half. So the transverse axis here would be the y-axis, or possibly something parallel to the y-axis if it's shifted. If it were a situation like this, where our hyperbola is mirrored across the x-axis, the transverse axis is the x-axis. So without graphing this, tell me whether the transverse axis is the x-axis or the y-axis for this example, and why. Well, the transverse axis is the y-axis. Because it comes first. That's our deal. Now, what I want to do is I want to construct a box, 4 points. Find the 4 points that will determine the hyperbola. The process is very similar to what it was for the ellipse in terms of finding those 4 points. So what I have is I have y squared over 9 minus x squared over 16 is 1. I want to find the 4 points that are going to define it. So again, this is working off some kind of a standard model like y squared over a squared minus x squared over b squared equals 1. So if that's our model, the a squared here we're dealing with is 9. So a is 3. We're traveling 3 in the y direction. B squared is 16. B is 4. We're traveling 4 in the x direction. If you want to say plus or minus here, that's fine because we go in both directions. So our center is 0, 0, going 3 in the y direction. 1, 2, 3, that's one of my points. Going 3 in the y direction. That's another one of my points. Going 4 in the x direction. 1, 2, 3, 4, going 4 in the x direction. 1, 2, 3, 4. Those 4 points are going to define my hyperbola. Now, how do we do that? So I guess I could list those 4 points. What are they? They are 0, 3, 0, negative 3, 4, 0, negative 4, 0. If this were a plus sign in between, those 4 points would be the vertices of the ellipse. But these 4 points instead are going to define our hyperbola. So let's go ahead and take a look at those on the graph. So 0, 0 is still our center. So we need 0, 3, 0, negative 3, 4, 0, negative 4, 0. And from that, I'm going to draw a little box. For example, x equals negative 4 as y ranges from negative 3 to 3. And we'll go ahead and make that green and dotted. Similar thing, x will equal positive 4 in that same range. And then y equals 3, y equals negative 3. So y equals 3 as x ranges from negative 4 to 4. And same thing with negative 3. So this is our box. So the next question I'm going to ask you is 2 things. Where are the vertices? So looking at this box currently, the question I'm going to ask is where are the vertices of the hyperbola? And also I want the equations of the asymptotes. So we want vertices and we want equations of asymptotes. So as we look at this, what are the vertices? What are the asymptotes? And remember what the equation was originally. The original equation is y squared over 9 minus x squared over 16 is 1. Vertices, here, 0, 3, 0, negative 3. That's a vertex. Why are those 2 things vertices? Because the transverse axis was vertical. Y came first. If Y comes first, the vertices will be on the y-axis. Now, the next thing I need are the equations of my asymptotes. So we drew this little box here. The equation of the asymptotes are the diagonals of this box. So from this first point, up 3 over 4, I believe that's y equals 3/4 x. That's your slope, 3/4 x plus 0. The y-intercept is 0. And the other one is down 3 over 4. So y equals negative 3/4 x. And I'm just putting the plus 0 for emphasis. That what we're dealing with here is a y-intercept of 0. So now that we're here, we should be able to draw some kind of a reasonable version of our hyperbola. We start at the vertex and then we grow out towards the asymptotes. Start at the vertex, grow out towards the asymptotes. Start at the vertex, grow out to the asymptotes. Start at the vertex, grow out to the asymptotes. So let's take a look at our original graph. It was y squared over 9 minus x squared over 16 equals 1. And you can see from the vertex growing to the asymptotes, if I zoom this out, you'll notice how that maintains itself. Now, the next question I want to ask is, what are the focuses? What are the foci? So what do we have as our original question again? Y squared over 9 minus x squared over 16 is 1. And the thing to remember about finding a focus of a hyperbola, c squared is one of these numbers plus the other number. C squared is a squared plus b squared. So when there's a minus for the ellipse, the focus requires a plus. When there's a plus for the ellipse, the focus rule requires a minus. So it's maybe a little opposite of what you might hope it would be. So in this case, c squared is 9 plus 16. C squared is 25. C is plus or minus 5 from the center. From the center. So where was our center? Our center was 0, 0. We go 5 on the major axis. So our focus from 0, 0 to go up 5. That'll take me to 0, 5. That's a focus. And from 0, 0 down to 5, down 5 to 0, negative 5. That is also a focus. Now, what is a focus in ellipses? It's the difference. If I pick a point on the hyperbola, like this point, if I take the distance from the lower focus to this point minus the distance from the upper focus to that point, that difference is always constant. If I subtract from here to here minus here to here, that's the same as from here to here minus from here to there. Whereas for ellipses, it was the distance to the focus was the same. The sum was always the same. Here, the difference is always the same. That's our basic idea. Now let's go ahead and move these things off of the origin. So what shall I look at next? Let's take a look at x minus 3 squared over 25 plus y plus 4 squared over 49 equals 1. So I'm going to ask you a bunch of questions. What is the center? What are the 4 vertices? And I would like to know, where are the 2 focuses? So see if you can answer those questions. Where's the center? Where are the 4 vertices? Where are the 2 focuses? Hopefully the center is pretty straightforward. We're shifting this thing. How are we shifting it? X minus 3 squared, y plus 4 squared, general form, x minus h squared over a squared plus y minus k squared over b squared is 1. You can see h is 3, k is -4. So our center is 3, -4. Let's go ahead and label that back on Desmos. So let's get rid of all of this. Center is 3, -4. Now, which direction are we going to go from the center? In the x direction, the number downstairs is 25. So we'll say a squared is 25. So a is plus or minus 5. So we're going 5 places to the left and 5 places to the right from our center. So if we take a look back at our graph, 5 places to the left, 1, 2, 3, 4, 5. That's what, -2, 3. -2, -3, -4. There we go. That is 5 places to the left of the center, 1, 2, 3, 4, 5. 5 places to the right of the center, 1, 2, 3, 4, 5 is 8, -4. We see that. Now, where do we go in the y direction? So in the y direction, we go, recognize b squared is 49. So b is plus or minus 7, up 7, down 7 from -4. So -4 up 7, -4 down 7. -4 up 7 will land at 3. -4 down 7 will land at -11. Let's go back to Desmos. Move this a little bit. So x value is 3, and then we go up 7, 1, 2, 3, 4, 5, 6, 7. So 3, 3 will be another one, and we're going to go down 7. That'll land me at 3, -11. Can't quite see it, but I'll move it up a little bit. 3, -11. So those are my 4 vertices. So I should be able to draw my ellipse that'll go through those 4 points. 1, 2, 3, 4. So let's do that. X minus 3 squared over 25. Plus y plus 4 squared over 49. And we hope it's going to go through those 4 vertices, and it does. So we have our center, we have our 4 vertices. Will they enable me to label these vertices? Or vertex? Sure. And now I need to get the focus, 2 focuses. And remember, the focuses lie on the major axis, the longer of these 2. So in this case, the longer of these 2 is the vertical component, the thing that is parallel to the y-axis. So let's go ahead and find our focuses. So what's our rule there? C squared for an ellipse is the larger number minus the smaller number. So this time I'll call it b squared minus a squared because b squared is bigger. So 49 minus 25, which is 24. So C is plus or minus the square root of 24, which is plus or minus root 4 root 6, which is plus or minus 2 times the square root of 6. So again, which direction are we going? From the center up to root 6, from the center down to root 6. The center is 3, -4. So 3, -4 plus 2 root 6. 3, -4 minus 2 root 6 are the two focuses, are the two foci. So let's go ahead and draw those back in on Desmos. And see what you get. So 3, -4 plus 2 times square root of 6 and -3, 3, -4 minus 2 root 6. And those are my two focuses or foci. And remember, looks like I moved one a little bit and it's fixed. Now it's fixed. The sum of the distances to any point on the ellipse is constant. So notice from here to here, the distance is 2. From here to here, well, not quite 2, almost 2. From here to here, it's almost what, 9, it's almost 12. So 2 plus 12, somewhere around 14. So if I pick any point and taken this distance plus the other distance, I should get that number around 14. Let's take a look at one more of these problems.